Hello everyone, this is Dr. G. Anita Hebsiba, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. We have been using textile material to have a very good appearance, to protect ourselves, to cover ourselves, etc. But there are certain applications in which textiles perform some special functions. We call them as functional textiles. Imagine um, a fire serviceman. He has to fight against fire. He cannot wear a normal textile what you and I wear. He needs a textile or else a dress which can protect himself against the flame and fire which he always work with. So in this video, we are going to discuss about a very interesting topic about fire resistant textiles, especially on the types and what else? Key parameters of fire resistant textiles. Let us go to the video. Fire resistant textiles, they are actually specially designed fabrics that will give us protection against fire, heat, flame, etc. And these textiles are widely used in industries where with the firefighters, military people, and then some industrial safety measures, and also in aerospace. What are the types of this fire resistant fabrics? There are many types, among them two are very important. The first one is inherently fire resistant fabric. And the very word inherently means that they have the ability to resist flame. So without any additional treatment or else additional chemicals, etc., they themselves have the ability to resist fire or flame. It is interesting to note that there are few examples of this category, that is Kevlar. It is a fire resistant fabric which is usually used for bulletproof and fireproof materials. And Nomex, here again it is a meta-aramide heat resistant fabric which is used in firefighter suits again. And then we also have polybenzimidazole, that is we call that as PBI, which offers a very high heat resistance, and it is commonly used in aerospace suits. And a carbon fiber which has high thermal resistance, and it is used in advanced fire protective suits. So these are some examples wherein these Nomex, Kevlar, PBI and carbon fiber, they themselves have the ability to fight against fire. Second one is treated fire resistant textiles. Here we give a treatment with either chemical or else a resin, like that, etc. Okay, you can treat either cotton, you can treat polyester, you can treat nylon, which can resist against or else flame and also the spread of flame. Examples are fire resistant treated cotton, fire resistant treated polyester, and nylon treated with fire retardant chemicals. So, and this is again another category. We give some treatment which these chemicals, they fight against chemical or else fire, and these chemicals are applied on cotton, polyester, nylon. And the third category is blended fabrics, where you blend Nomex or Kevlar with a cotton. This can give you best comfort, whereas normal Nomex or Kevlar cannot give you comfort, but it can give you 100% protection from fire, but it cannot give you comfort, and it is somewhat expensive too. So now you blend that with cotton. It gives you comfort, it gives you cost, what else? It is cost effective, and also it is protective against fire. So monocrylic and cotton blends, these are the two important blended fabrics. Next slide, we will have a very a good comparison between inherent flame resistant fabrics and treated flame resistant fabrics. Okay, so inherent flame resistant fabrics, they have that is the built-in ability inside the fiber itself, whereas in treated flame they are achieved through chemical treatment. When it is inherently built inside, it is permanent and it is lasts for lifetime. But when it is treated, the treat may go off for after a few washes, so it is not permanent, it is temporary. We have examples we have already seen in the previous slide, and when compared with the cost, it is more expensive. That is, the inherent flame resistant fabrics, they are more expensive, but treated one are somewhat economic. And flame retardant expensive fabrics, they are somewhat soft initially, but newer versions, they have got some more added comfort properties inbuilt in them. And then flame resistant fabrics which are treated, they typically soften based on the base fabric. Okay, if it is a polyester, again it is not going to absorb any moisture at all. Okay, so maintenance, normal care is needed. No special treatment is required for inherent flame retardant fabrics, but in the case of treated flame retardant fabrics, it requires more extra care, because the treatment may go off after few washings. And the next one is what are the uses? Here we have firefighters, military uniforms, aerospace. There we can use for industrial clothing, upholstery, etc. And then effectiveness, highly and consistent throughout the garment's life. But that is not more consistent throughout the garment's life. Again, coming to the types, uh, apart from inherently flame retardant fabric and then treated, we have blended and now coated. So here we have a specific coating. It is not simply finish. It is coated like silicone, PVC or polyurethane coatings are given to provide flame resistance. For example, the tarpaulins we commonly use for military tents and all, and for domestic uses also we use tarpaulins. So they are highly resistant against fire. And then protective upholstery materials, they are also examples of this category. And then intumescent fabrics. Here, these fabrics they are coated with special coatings and that expand when they are exposed to heat, and they form a barrier from the what else, the flame and the material. So such kind of that is intumescent fabrics are used in fire curtains or industrial protective covers. What are the key properties? These flame retardant fabrics should be slow to ignite. They should not catch fire all of a sudden and they should not burn. Self-extinguishing behavior. That means they should not spread the flame. They should have the ability to extinguish the flame, that is quench the flame. That is one of the important property again. And the low heat release. That means it should not what is a very small spark, it should not provide heat to the entire environment all of a sudden. And then reduce melting and dripping. When, for example, when you take polyester nylon, they melt and drip very fast. It should not be like that, because then it will just stick onto the body and it will cause more problems. And it should maintain the quality after exposure to flame also. It should be reusable. Okay, so after exposure to flame, it should not be thrown off. Okay, in that sense, these are the key properties. Thank you.